How's everyone doing this morning? Welcome to the Build After Party. I hope everyone enjoyed the session. Oh, wait. This isn't the after party. We'll have the after party after this, I guess. So we're going to be talking about, I'm Juan Perez, part of the Azure IoT team. And this is Nicole Birdie.
Hi, I'm Nicole Birdie. I'm also at Azure IoT. We're both program managers on said product.
Yeah. So we're really excited. Thank you for making it this morning. Really excited to get started here. I'll be back in a little while. Nicole will go through a bunch of things, and then we'll go through a bunch of transitions, and hopefully we'll show you some demos, and hopefully the demo gods are with us this morning. Everybody brought the demo gods for us?
I think we made the proper sacrifices last night at the
Yeah, we had some
party.
sacrifices. Nothing worked last night, and then this morning everything worked, so that was really nice. But yeah, I'll be back. Thanks a lot.
All right, good morning, everyone. I'm really excited to see so many people at the bright and shiny 9 a.m. So as Juan mentioned, we're going to talk to you all about how you control, configure, and basically manage your devices over the entire lifetime of the device. From the moment it comes out of the box, plugs in for the very first time, to the moment you have to sunset it at the end of its useful life, 10, 15, 20 years down the line. So I want to talk about this in terms of the device lifecycle, which, as it says, should be pretty straightforward, but you have to kind of plan this out. A lot of folks try to skip steps here to their detriment later on, and we've talked to many customers in our time working on Azure IoT who've tried to do this, which is why we've presented this beautiful wheel. So the first step to the device lifecycle is just to plan what you're doing with your IoT process in the first place. Why are you doing IoT? You should have some answer for that. And from there, the idea of what type of device are you using kind of springs from that. So once you've done your homework, you know why you're building an IoT solution, you've created the type of hardware or you've purchased the type of hardware, then it's time to provision the hardware, which is how do you hook your hardware that comes out of this box up to the cloud solution that you're going to be using to control and manage and modify these devices with. So after that, it starts into the kind of the rinse repeat cycle of configure your devices, make sure that they're set to the right temperature, set to the right color, the right motor speed, whatever you or your customers want to have that device be set to. And then you monitor it and make sure that everything is going well on the device. Is it still configured properly, or is it out of compliance? Is it running a little hot? Do I have to send the maintenance guy out to go fix it? And then after you do the configure monitor cycle a couple times, you'll eventually decommission the device at the end of its useful life. So at that point, you kind of start the wheel over again as you try to create what the V2 of that product's going to be. So that's probably 10, 15 years out for most of us here in that room. So there are a couple principles of device management that just are general things to keep in mind. And the first is scale and automation. So this is doing something for one device is easy. Doing something for 1 million devices is a completely different ballgame. And what Juan and I work really hard on in our day jobs is making sure that we enable you to scale and automate for however many devices you're using IoT Hub without having to do anything special sauce under the hood in order to make everything work well. We also are very strong believers in openness and compatibility with what we release to our customers. So we have a whole variety of open source SDKs that run on a variety of operating systems, variety of languages, et cetera, that we maintain and make available to you to make your development lives easier. You also have to be aware of what's the context in which this device is to be used, because that does make a difference in how you manage that device, when you can send firmware updates, how frequently you update the firmware, how you manage and monitor that device, kind of all up from the ground up. And then last but not least, you'll have to service many different roles. There's not just a pure developer and pure manager that you have to think about in the device lifecycle. You also have to think about who's that person doing the initial deployment of the device. Who is the person that's getting sent out to go update the device or to go maintain the device and replace a broken gear or a broken, a fried motherboard on the device? And what do they need to know in order to make their lives easier? What types of items you need to have on the truck that get sent out to service, the elevators, for example? And to all of those goals, we have a whole slew of different features available in IoT Hub today, well, almost all today, that you can have at your disposal. And the only one that's the almost is the first one about device provisioning, which is something we pre-announced a couple weeks ago and will be available this year for you to consume publicly. So these are things we're going to get to in more detail, so I'm not going to bother reading this slide to you because it's a lot of words. So I want to get started and talk about IoT Hub device provisioning. And this is really the first step of the device lifecycle in which the device itself matters. And it comes online, and what do you do for that first time? But before I get into what we are doing with the IoT Hub device provisioning service, I want to define my terms, because if there's one thing I've learned over the years working in IoT, it's that different words mean different things to different people in different contexts, way more in IoT than they do in most every other area of tech, just based on the long storied history of IoT and M2M. So when I say provisioning, I really mean two things when you're provisioning a device. The first is you register that device to the right IoT backend, and that's, in this case, the right IoT hub. And then the second step is you give that device an initial configuration that it needs to be a fully prepared device in the context of that solution. So you can think of like checking into a hotel. You go to the concierge, and the concierge will give you a room key. And you go to that room key, and everything is prepared for you already. So you're ready to go in the context of that situation. So with device provisioning, that's what we're doing for IoT Hub. So we pre-announced this device provisioning service, and I want to give you a couple more details that I didn't go into in the blog post that we went with the pre-announcement. And that's just some of the ways we're thinking about device provisioning. And first and foremost is that devices are automatically and securely connected to the IoT Hub service and provisioned with an initial configuration. This should be pretty straightforward, but it's really the secure part that I want to dig into a little bit here. Because what we're doing with automated device provisioning is we're starting the security root of trust in that device from the moment that device boots up for the first time, which means that it continues to have the entire rest of the life cycle with a secure root of trust and ideally some sort of hardware security module so that it's really, really difficult to get to the keys. And based on the security model we have in IoT Hub, you can't actually reach into the device. The device has to initiate all outward bound communications, which means that the device is just that much more secure from the moment it turns on for the first time. Now, one of the things that we've encountered a lot talking to customers are various types of multi-tenancy type of scenarios. And in order to do that, and a couple of other scenarios that I'll explain or expand on a little more in a minute, we want a single instance of the provisioning tenant, or like one instance of the device provisioning service, to be able to talk to multiple IoT hubs across various regions. So this is more something that you, as somebody who will be using the device provisioning service, will say, hooray, I don't have to worry about this. But it's something that I take back to the engineering team and say, this is something we absolutely must do for our customer scenarios. Another thing that we want our customers to do is be able to just write rules and logic that they use to set up how their devices will automatically get assigned to an IoT hub. And this should be as easy to do as possible. You shouldn't have to take a 300-page book in order to learn how to do it. It should be pretty straightforward. How do you do that? And then we want to make the device provisioning service eventually extensible with support for different identity attestation patterns. I'll get into the one that we will be supporting when we go public later this year. But what this means is not only just different ways of provisioning a device, but also different ways of attesting to that device's identity. How do you know that the device is who it says it is when it first checks in with the device provisioning service for the first time? And there are a couple of different ways that we're doing that. Before I get into those, I do want to talk about some of the scenarios that we're thinking about with device provisioning. And ownership-based is clearly a winner in every sort of multi-tenancy scenario. In this case, you've got a whole bunch of devices that are all very similar that somebody is reselling to a bunch of different of their customers. And they don't want to say, OK, well, these devices go in this bucket, and these devices go in this bucket, and these devices go in that bucket. And then we'll take them out individually, bucket by bucket, flash them with the right information for the one customer they get sent to. We want that to happen automatically when the device turns on for the first time. And that's something that you'll be able to do with the device provisioning service. Similarly, geolocation is a pretty big scenario, and that's where if I sell smart toasters, and I make the best smart toasters on the West Coast, right here in Seattle, and I ship my smart toasters worldwide, I don't want to have a separate toaster SKU for Western Europe and a toaster SKU for Southeast Asia and a toaster SKU for Australia. I want to have one toaster SKU because I sell one type of toaster. And then when that toaster turns on for the first time, if it's being plugged in Perth, Australia, I want it to be provisioned to the IoT hub in the Australia data center. Seems pretty straightforward. Right now, it's actually a pretty complex process that involves, OK, well, where is it? Doing a lot of coding yourself. What you should be able to do with this is you click the, do by lowest latency in geo. Done. And then finally, reprovisioning. So we mentioned the life cycle as being a cycle. And one of the things that happens over a lifetime of the device is things change. Maybe the device gets sold, maybe the device moves around, maybe something else happens to the device and you have to do a hard reset because you don't know what happened, and it's kind of the last-ditch effort to debug the thing. Reprovisioning is definitely something that we are keeping into account as we're building the device provisioning service to make sure that this works no matter where on the wheel you are. You can go back to the device provisioning service and say, am I still connected to the correct IoT hub? And the answer is yes, you can be able to do that. The way we're doing this is through a concept called the enrollment list. And the enrollment list is basically an allow list of all the different devices that are allowed to connect to the device provisioning service and be eventually connected to an IoT hub. And this isn't just a single device, but you can also do groups of devices as well. So you have individual enrollments in case you need per device identity and per device initial configuration. But you can also do group enrollments. So if I want every single toaster I sell to have the same configuration, I can have a group enrollment for all my toasters. And as long as I use the same sort of identity attestation, like for example, if the certificate that device presents to the DPS is signed with the same root cert, awesome, great. We will allow that through the enrollment list. One of the other great things about the enrollment list is that all the configuration updates that happen throughout the supply chain process of the device getting produced don't involve touching the device anymore. So if, as the device moves along, its configuration gets tweaked along the way, you just make updates to the enrollment list, and you never have to take the device out of the box and reflash it and put it back in the box, send it along the way where it then gets taken out of the box and reflashed and then put back into the box. Rinse, repeat, depending on how long your life cycle or your supply chain is. You can just modify the enrollment list, and when the device comes online, it just has the latest and greatest and says, oh, thank you for that initial configuration. Let me go apply that. So before I show the demo, I want to explain what's happening, because the great thing about automated device provisioning, and it makes your life a lot easier, the bad thing about it is that it's kind of a boring demo because you watch and nothing, like I don't do anything, and then suddenly something changes. So here's what's going to happen behind the scenes, but I first want to set the stage of what's happened at the initial setup. And first is that the device already has the URL for the provisioning service at first boot. The provisioning service URL will be a global endpoint, and the service will figure out everything else about where that device is supposed to go. And what this requirement basically says is that you set up the device to know who to talk to find out where to go. If the device doesn't know that, I can't help you, because it needs to know something of where to go in order to find out where it's supposed to live in the future. Similarly, the device provisioning service already knows about the IoT hubs it can connect to, and it already knows the types of identity attestation information that each device is going to use. Is it using a DICE certificate in order to attest to its ID? Is it using a TPM? Is it using some other sort of cert? What have you? That information is all stored in the enrollment list, as well as the initial configuration of these devices. So what happens when the device turns on for the first time is it says, hello, device provisioning service, I'm a device. Here's some cryptographic information about me. Where do I go? And the device provisioning service will look up that device in the enrollment list. It'll do a handshake with that device to verify its identity. And it'll say, OK, great. Thank you, device. You are a valid device. I believe you are who you say you are. And I will go create an IoT hub identity in the left IoT hub, because that is what you match based on the information I know about you. So the device provisioning service will say, hey, IoT hub, let me create a new identity and populate your initial desired twin state. And IoT hub will say, thank you, here's some connection information, which the device provisioning service gives to the device. Now, at this moment, the device can connect to IoT hub and receive information from IoT hub and exist as a happy device throughout the rest of its days talking to that one IoT hub. If it does need to reprovision at some point, it goes through this exact same process where it reaches out to the device provisioning service and says, hello, I'm a device, where do I go? And the device provisioning service goes through that whole song and dance again. So let me show what that looks like. And before I do that, I want to explain a little about the demo I'm about to do. So here is the device. I've got a video so you don't have to squint. It's a Raspberry Pi because it's got a screen. And this one's using a TPM on the back, which is just a little hardware chip. And what I've done is in the portal I have set up, here is the device. I want it to be called Windows 10 IoT TPM. And I've set an initial device twin on this device so that the string to display will say, this device has been provisioned, because right now it says this device is not provisioned. And I want to change the background color of a box that's on the screen to be aqua. So it's pretty straightforward. So let me change that. So here you can see a zoomed in version and see how it says the device is not provisioned. I press the button and now the device reaches out to the device provisioning service, does that handshake, gets the connection information for IoT Hub, receives the initial device twin and applies it. And you can see that I couldn't even finish my explanation in the time it took for it to actually apply that desired state to that device. So this is just a cute little demo. Thank you. So this is just a cute little demo that I did to show something on a screen that's easy to demo repeatedly over and over. But where this really shines is, what if this wasn't just a Raspberry Pi? And what if this was something more complex, like a car? And I have a custom car that's been sport-tuned to have the best ride for the roads in my region. And I just have to buy my car, drive it out of the dealership, and my car is ready to go. And once you start thinking about things that you can do in that sort of way with automated configuration of the device, suddenly everything becomes a lot easier, and you really reduce the time to get value in your customer's hands by saying, hey, yeah, just plug it in and turn it on. We don't have to do any initial fiddling with it. And it just is a better experience for everybody involved.
That was really cool, Nicole. So once a device is initially configured, then configuration, as you know, is a life cycle in its own. And we've actually, at Microsoft, we've done configuration management for some time. We manage the cloud, and we've had servers, and servers have been configured in data centers. So there's actually quite a bit of history here that we're learning from in IoT. But IoT is a little bit different. So that's what I want to talk about here. In a data center, you have essentially a bunch of servers, and you have the ability to use the network, and usually it's a high bandwidth network. And so when you use a configuration management type system, you're going to provide some configuration. You maybe use something like desired state configuration out of the PowerShell or Azure management. And you can depend on these things like the high bandwidth configuration, the high bandwidth network, and also the power grid. Now, in IoT, one of the things that we realized really quickly was that we have an incredible diversity of devices, right? We have some devices that are really tiny. We support devices down to under 100K microcontrollers, which we'll show some today. But we also see that, of course, you have gateways that help those devices translate protocols and do on-the-edge processing. And then you have very heavyweight devices. I've seen customers that have multiple servers as their IoT thing. And so that makes it really incredibly challenging to deal with because of all that diversity. As well, the other thing is that often the networks are not the same, right? We have a diversity of networks. We've seen all kinds of different networks. And so sometimes these devices are connected to the power grid like we're comfortable with, like where we come from. But often they're battery-operated devices. And so again, when you think about the protocols that you're interacting with these devices, are they chatty? Are they going to drain my battery? Are they pinging the server all the time? So we've thought about all these challenges, and what we've built, it really accounts for all these things. And sometimes those devices are connected to fixed high bandwidth networks, but often they're connected to 3G, 4G, LoRa, narrowband IoT, satellite. We've seen all kinds of crazy things. IoT is a lot. There's a lot of custom protocols as well and custom RF technology. And so with Azure IoT Hub, what we do is we abstract all this complexity, and we enable you to do configuration on top of all this stuff. And so this is key. The key part of this is really the device twin. And so I'll talk, essentially the device twin allows you to program against your devices without having those devices, without having to know about those devices. And so for example, I could provide a configuration, and as Nicole showed, you can provide an initial configuration with a device provisioning, with IoT Hub device provisioning. And then once that is set, then essentially you can then continue to evolve that configuration. And to evolve that, what you use today is jobs. And jobs are about scheduling and broadcasting twin updates. So essentially, what that means is that I can schedule, for example, the update of a set of devices targeted by a query that is a function of the state of that device. Say devices that are in building 43, floor 2, I want to set the configuration of how frequently I want to send telemetry or the background lighting on a stage at a certain time. So essentially, you use jobs to broadcast and schedule the updates to those configurations, to the device twins, and then as those devices connect, independent of the state of the device, because of course the device twin is always connected, it's in the cloud, right? So as those devices come back and connect, they'll pick up those configurations, they'll act on them, and then periodically they'll start reporting back the status and conditions that they're in. And so what's nice about this is that as a cloud application, as a cloud backend application, you can then query for devices that have provided their conditions, and then you effectively are proving compliance to whatever policies that you've defined through that configuration. Another thing that is very interesting here is that we're announcing now that we're now also supporting, in addition to queries, events for property change notifications. So this is really great because often in a portal where you have an operator, you want to be able to zone in on one or a set of devices and deal with the changes that are happening on those devices without having to query for and pull for the status of those devices. So now you can essentially use the Azure IoT Hub routing feature, say, hey, I want property changes for conditions to prove policy, to test the policy and compliance directly on these set of devices and get those events. So that's pretty exciting. So let's talk a little bit more about the device twin. How many of you have used a device twin before? Great. That's really exciting. That's a pretty big number. So the device twin is essentially a JSON document that's managed by IoT Hub that allows you to interact with a device without the device having to be there. And it's broken into 3 sections. The first section is the desired properties. And the desired properties allows you to configure devices, and you can write desired properties from the cloud. So this is, from the cloud, you usually have an operator portal, an application, and you'd be able to essentially write those properties. And like I said, you can use jobs to scale that out. Once the desired properties are set and that device comes back and connects, as I showed in my previous flow, the device implements that configuration. And that configuration, we are not opinionated about what that is. It could be anything you want. And so essentially, you get updates. You can register for updates on a device and get those updates. And once those updates are set, or at any time, you can report your conditions through reported properties. And reported properties flows the other direction. So like I said, on the back end, you can then query and receive events on updates for your devices. Now, these events are actually much bigger. On the left side, you have events that are coming to a specific device. On the right side, you have events that are coming from a number of devices. So you can imagine having a population of 100 million devices and getting events or querying for those states, and then being able to organize those devices to say, these are my healthy devices, these are my not healthy devices, and of my not healthy devices, these are the reasons why they're not healthy. And so as you define your configurations, think about also what a device that's unhealthy looks like. And you can use those definitions and you can build queries that can filter those devices out. So for example, say that you say, these lights here should be a bright white, and one of them's red. Well, you can query for devices that are white, and then you can query for devices that are not white. And so you can then partition out for an operator, partition out the set of devices that they're going to have to act on. And that's really, when you think about an operator, they wake up in the morning, they go to work, they look at their dashboard, and they have to figure out what they're going to do next, what fire they're going to put out. And so this is essentially what's going to help you do that. In addition to this, there are tags in a device twin, which the physical device itself doesn't really care about. Tags are things that you use to organize your devices so that you can then find them later, right? So these are my devices that are in building 43 on floor 2 in this room. These are my devices that are at this gas station. These are my devices that are in this warehouse, for example. This is the slide that's going to get me in trouble. So this is a preview of the portal experience where we're adding device twin capability. And so what you're seeing here is essentially, what I wanted to show here is that the device twin is a JSON document. As you can see, there's tags. It's kind of hard to read, but there's tags, and there's properties and desired and reported, and there's a bunch of keys, and you can query for your devices as a function of those conditions, whether they're tags or reported or desired. So part of what we released with our device management release in November of last year was everything that I've talked about, everything Nicole talked about except for the provisioning stuff. So twins, methods, jobs, queries, and so on. But on top of that, we also released a number of device management patterns, because when you ask people about what is device management, the first thing you hear is firmware update, firmware update over the air. You hear, I want to reboot my device remotely, right? And so on top of those building blocks and those capabilities are these device management patterns. Now, I want to make this point, because those building blocks are actually useful for many other things other than device management as well, right? It's you can imagine saying, I have a warehouse, and all the doors on my warehouse need to be closed before I set the alarm, right? Well, you can use the device twin to also report the status of all the doors, and only when you query for all the doors and they're all closed will you then set the alarm, right? And you can imagine building very interesting workflows downstream of that. But we also have the device management patterns, which is what everyone was asking for first. And so these device management patterns include firmware update, reboot, factory reset, and software update. And what we did is we released these patterns. We have some documentation. We have also a set of libraries that simplify this process. Now, the main point here is that because we don't deliver any devices ourselves, then we cannot implement firmware update. If you've ever implemented firmware update, which we'll show you a demo here in a second, you know that every device is very different. When you actually copy the new image to wherever you're storing it on the device, the different devices have requirements of where you put that image. How does the bootloader interact with that image, and so on. And so by providing these building blocks and these patterns, we're hoping that you all will implement these patterns on top of your devices. And we'll show you some of that later on. So let me talk a little bit about specifically the firmware update pattern. In addition to using configuration, because you could do this with the configuration with a device twin, direct methods are actually a way of interacting with a specific device with low latency, essentially. And so if you think about, for example, turning on a light or turning off a light, right? You want to, for example, and say you're diagnosing a situation where the light is not turning on, or you're setting a temperature on a thermostat. You really want to interact with that device specifically. So you might have a mobile app that's changing the state of that light. You don't want that information to be queued so that when that device then connects, you start seeing the light come back on and off, right? And so that's essentially why when we listened to our customers, we heard that, great, C to D messages are great, they're queued, but they wanted a very, very lightweight and essentially low latency way of interacting with a device. And if that device is not connected, I want to know that right now, right? I want to know that light is not connected. I don't want it to wake up and start flickering back and forth. So direct methods is how we enabled that scenario. One way of enabling firmware update with this pattern is through methods. And so you initiate that firmware update through a method, and you say, hey, device, please firmware update, and here's your URL for where you should go grab your image. Now, this could also be implemented with a desired configuration through device twin. And the device side is essentially the same code, except for the subscription of where that information is coming from. So once it receives that information, it responds. So it immediately goes back and says, hey, I received it, and I'm going to start downloading the image. And at that point, it's the responsibility of the device to go through the flow of whatever firmware update implementation you have, so that as it's happening, you can then have an operator dashboard describe that device. So now we're going back to that situation where you're able to query out for devices that are in the middle of a firmware update, query out for devices that are in the middle of a firmware update, but the download failed for whatever reason. And again, you start to segment. So at the end of the day, you want to figure out what's happening with your population of devices. As that download completes, the apply image happens. You again report status, and you can then again see that those conditions update. And finally, you reboot and you reconnect, and then the device comes back to life. So what I want to do is I actually want to show you code, because this is build after all. I want to show you code of how this works. And again, what I'm going to show you here is this is not an implementation of firmware update on a device. This is the cloud backend application and a simulated device that doesn't actually do a firmware update, and you'll see it in the code here in a second. So what I'm showing you here is the service side of the firmware update. And if you've used IoT Hub before, this is the Node.js SDK. We have a number of SDKs for all kinds of different platforms and languages. But what I have here is a very, very simple app. It essentially connects to IoT Hub as a service. So I'm using a service connection string here. And then it does two things. It invokes the firmware update, and it displays the firmware update status. And it displays the firmware update status by essentially just consoling out the device twin. So let's go, and I'll show you exactly what I mean by invoke firmware update. This is very, very simple. So you basically call client.invoke device method, and you pass the firmware update name, which is the method that the device is going to handle. And you pass some path to this is the proof that this is fake, right? Essentially, it's fake in the sense that the device, this is not an actual backend application, this is not a real device, but IoT Hub is real, so we're going to hope that Wi-Fi works and that we'll get all this information going through to the Azure cloud. And after I invoke that method, I'll get a response, I'll output that response, and then here I will go through a 3-second loop that will just essentially do a console.log with reported properties. Super, super simple. On the device side, I'm going to connect as a device, and I'm going to register for the device method with the client.onDevice method API for the firmware update method. I could have called this anything. I could have called this, closed door. That's the point of the device management patterns. We're being somewhat opinionated and providing guidance and libraries on how to implement this. And once that happens, I'm going to do a couple things. First of all, I'm going to make sure that this is a secure connection. And so I'm going to use some of the Node.js libraries to figure out, is this an HTTPS protocol? If it's not an HTTPS protocol, then being used over TLS, then I'll respond to that method with a 400 error. Now, you might remember, this looks a lot like a web request, a web service, essentially, right? So that's essentially what we're enabling with direct methods on a device. And it looks very, very similar from the cloud, but you're calling a web service on the device, right? And so if that protocol is HTTPS, then we send a 200 and we're on our way. And what I mean by on our way is we're going to initiate the firmware update flow. Again, this flow is managed by the device. So first thing it's going to do, it's going to download the image. And then right after that, it's going to apply the image. And this is just a very, very simple, using the async library on Node.js to do two sequential things. And in that process, what I'll do on download image is the first thing I'll do is I'll report my update through my twin that I'll say I'm downloading. I'll put a timestamp so that when I go and figure out which devices have been trying to download the firmware but haven't been able to, I can actually do some calculations on when that started, when it didn't transition, when it did transition, and so on. And then I have replace this line with the code to download the image, right? So this is the part where that's fake. Essentially, all I'm doing is I'm waiting 4 seconds. You would replace this part with the actually go fetch this image, this file from Azure Blob or from wherever you wanted to download this from. And apply image does exactly the same thing. So let's go ahead and start this. OK, great. So my device is now connected to IoT Hub, and it's waiting for my firmware update device method. Now I'm going to go back to the other VS Code instance, which is the service side, and I will run this. And I'll hit my breakpoint. So now I know I'm good. I'm connected to IoT Hub, and I'll go ahead and let this roll so that I can see that I've caught my method. So I'm not going to take too much time here. I'm just going to go ahead and let it go. It was HTTPS. I send my response, and I'm going to go ahead and initiate my firmware update flow. Now let's go back here, and I'll show you that essentially this guy is now already on the service side reporting the different conditions because I have it on a loop, as I said before. So I'll go ahead and let this go, and I'm going to start the waterfall. And then the first thing I'll do is I'll report back that I'm downloading, as you can see here. And you can see that the patch, all I had to do to do this is I have this JSON object, essentially, that I'm saying twin.properties.reported.update with this patch, and I'm good to go. So I'll go ahead and send that. The device will then spend 4 seconds proving that, of course, we can download that image from somewhere. And then we're going to complete the download, as you can see at the bottom right here. I've now completed imagine if we completed the update, the download. I'm going to report this. I'm going to start applying. It's going to take 4 seconds to apply it, and then I'll send the apply firmware complete. So that was it. That's the whole thing. Now, on the other side, I will have been able to see that all of my transitions happened in a certain period of time. You can see that this was actually right now. So this was real in the sense that the messages are flowing back and forth, and the twin is being updated, and the method was initiated, and all of that happened. So that's essentially the firmware update pattern. Now, we're going to show you that for real on a ST device, ST microelectronics device. So I want to introduce Manuel Cantone from ST Microelectronics, and we're gonna actually show you another demo that is the real device doing the real firmware update. Thanks for coming. Really great to have you here.
Thanks, Juan. My name, as Juan introduced, is Manuel Cantone. I'm an IoT marketing manager with ST Microelectronics. And how many of you know ST as a brand? Good amount. My next slide would have been you're wearing something with some of our components, or you have something at home that has some components of ours at home. And we're one of the major semiconductor firm in the world. And we have a broad portfolio of microcontrollers, sensors, and we're a leader on those two segments, but also analog and RF connectivity product. What we're showing today is our development kit to connect to Azure Cloud, and it's called P-Nucleo Azure One. This is the kit that Juan is connecting right now to his laptop.
And there's a light here, so that proves that it's really IoT, and it's live, and I hope it works.
Thank you. It basically implements a smart thing that is connected through Wi-Fi to the Azure cloud. It's based on an ARM microcontroller, low-power, battery-friendly Cortex M4, and it has a full set of sensors to sense the environment and motion. And one is connected to the Azure IoT, and it's running the device SDK, our porting of the device SDK. So we're switching to a live demo.
Great. So what we have here is TerraTerm on a USB serial connection, and what it's showing is that this device is connected to the Wi-Fi here, and it's actually sending messages to IoT Hub. So I've already connected it. It's running. What I'm going to do is kick off a firmware update in the same way that I just described. But in this case, it's not going to be a fake URL. It's going to be a real URL with a real image that we packaged that's going to change this firmware version from 199 to 200. And so we're going to prove that by showing you some debug output. But I'll get that started right now because it takes a couple minutes, and we'll be able to very quickly see that. So let me run this. And once it starts, you'll actually see the firmware update. The device received the method. It's starting to download that image from Azure Storage. And go back to you while we wait for this to complete.
Just a few words of what you can do with this. It's, again, a sensor node connected to Wi-Fi. It has a full set of sensors to sense motion and environment. On the motion side, we have an accelerometer and gyro combo, a magnetometer for heading, and a pressure sensor that can be used as an altimeter. And then it senses humidity and temperature thanks to a dedicated sensor.
Great. So we're seeing here that the over-the-air we received the image. We're not going to be we completed the download. We're applying the image. So we're going through the same steps we just discussed before, and it's going to now reboot and reconnect. The thing I want you to keep your eye on is this 199 right here. It's going to change to a 20, and that's the magical part of this whole thing. So I hope you enjoyed as much as we do.
And while you're waiting, there's also an NFC dynamic tag on board that can be used as a provision method, and our Wi-Fi module. There you go.
So there it is,
again.
Version 2.0.
Perfect.
We did a live firmware update. Super exciting. Thank you.
Demo gods are with us.
Great.
There you go.
Thanks a lot, Manuel.
Thank you, Juan.
So you may have seen just about a month ago, the Windows 10 IoT device management team announced a number of capabilities around device management. What's really exciting about this is that the folks at the we've been working with the folks on Windows 10 IoT Core to enable the exact same endpoints that they have in Windows 10 through the device twin. And so if you check this out, this is all open source, just like all our SDKs. You'll see how they've implemented the use of device twin and direct methods. But more importantly, you get to benefit from it. So you can literally go buy essentially a Raspberry Pi, put Windows 10 on it, and start using their libraries that underneath the hood are then using the device twin and the direct methods that we were just talking about before. One of the things that we wanted to use this opportunity to do is to talk about some of the learnings we've had over the years. I've kind of touched on a few of them up to this point, but I wanted to go specifically to one, which is often I hear, we and the team hear, I'm trying to send messages to the device to configure it. And the first phone call says, hey, the TTL on your cloud to device messages is too short. And we ask, well, how long would you like your TTL to be? And they say 6 months. And so we say, that's probably not, so what are we trying to do here? And we end up realizing they're trying to do configuration. And so that's one of the reasons why we built Device Twin. And so please don't use C2D messages for configuration. It looks like it's going to work, but then you have all kinds of problems when the devices, for example, have their own life cycles. They might be off. You might try to be updating a bus. That bus has people on it. It's going to receive that message, but then it's going to, or maybe not receive that message because it's offline, and then the TTL will expire, and you'll have to do all kinds of retry logic, and it just becomes a mess. There's a really good reason to use C2D messages, and it's not for configuration. So I just wanted to stress that, and once you start using Device Twin, there is no TTL on Device Twin. The Device Twin provides updates, and we also do versioning on that Device Twin, so you can actually see what version every update comes as you receive those events on the device. And so it's a much more fit-for-purpose experience for doing configuration. Also, direct methods are great for interactive and diagnostics or troubleshooting type scenarios, or interactive, like I was talking about before, turning on and off the light. If you want to do a firmware update with a direct method, that's a scenario where you have a situation where a configuration didn't work, maybe, and you're going back to the operator portal and you're figuring out, okay, these 2 devices out of my 10 million didn't update. Let's try to do something else. That's a great example of use of a direct method for doing a firmware update, as we showed before. And like I said, do use the device twin desired properties for configurations. You do use the direct methods for remediation, and of course, reported properties, as we've talked about, for configuration compliance. It's just it's really, I mean, we really try to listen, and as you get, we're really excited about what you're building. We've seen some really amazing applications of Azure IoT. We're really excited to see the implementation from STMicroelectronics, the Windows 10 implementation, other implementations that are coming from all different types of partners and customers. And so our ask of you today is to go use this, come back with crazy scenarios, interesting scenarios. We're learning at the same time as everybody else with IoT, and so that's really an exciting thing. And the opportunity is pretty incredible to be able to leverage these devices and the diversity of devices and diversity of networks that we have. Another thing that I wanted to call out is to do a shout out for the remote monitoring PCS. PCS is a pre-configured solution in our Azure IoT Suite offering. And so the PCS is essentially a open source solution that has an ARM template that you can use to, in 5 minutes, stand up an entire IoT solution with simulated devices. The good news is that the PCS team has delivered support recently over the last 3 months for device management, device twin, direct methods, all of this goodness that we've been talking about today. And so you can actually use that as a starting point, use it as a demo, use it as a starting point, and use it to learn about how this stuff works as well. And it's really easy to get started. Lastly, I just wanted to point out that we've been talking about device management from a lifecycle perspective. And so as you think about device management in IoT, think about the lifecycle of devices, think about the way that the devices operate, the environment of those devices, the meaning and the purpose that you're giving those devices, and then and then start from there, think about the problems that those devices are solving, and then think about the rest of the cycle as Nicole showed. So I want to thank you all. We're going to, oh, one thing. We did really great, right? So we're going to get awesome scores. Thanks to we're really grateful for your fantastic scores. No, seriously, you know, we have evaluation forms. Please do fill that out. Provide feedback. It's good feedback is good feedback. So please provide any feedback, and we'll take some questions. Thank you so much for coming. Stick around. If you don't want to stick around, that's cool. But please do stick around, and we'll be here for a little while. And if you have any questions, we have microphones as well that we can take some questions. Thank you.
Hi.
Hello.
Hi there. This is Ahmed. Going back to the demo for Cortex M4,
Yes.
was it an embed OS?
No.
Oh, okay.
No. This was a firmware. This was a firmware implementation directly on the device. So there was no OS. It was just a straight C implementation that is
Okay.
it gets
So
something.
so let me ask it differently. So if I have to provision Cortex M3 or M4,
Yes.
and one of your step was basically certificate authentication.
Right.
So my question is, do you use OpenSSL or do you recommend any other like Seazel or Wolf SSL as a client-side?
Yeah, you can use the SDK, which I believe uses OpenSSL. And in this case, we didn't have an OS. We just had firmware. But you could use you know, FreeRTOS or whatever OS that you wanted to use on this microcontroller, which uses whatever library that it needs. If we don't support it, we also have a porting guide that allows you to port the entire stack to whatever stack you want.
Right.
Yeah, to answer your question about what SSL stack,
Yeah, because
let me answer. We allow you in our SDKs to specify which SSL stack you want to use. So there might be one reason or another based on your specific scenario to use one SSL stack over another. Fine, sub them out.
Exactly. In fact, this device is actually using SSL on the Wi-Fi board. So the firmware is actually leveraging the hardware SSL implementation on the STM32 Nucleo board.
Yeah, no, I agree. I mean, like for M4s, yes, you can use because they're 1 GB. But below that, when you're dealing with 20 MB flash drive, and it's hard to port OpenSSL, right? It's like
I see.
low battery, low bandwidth. So
great. Thanks a lot.
Thank you very much.
Yeah, thank you.
Hi. Is there the concept of a device being out of service? Say it's a device that's got users that walk up and interact with it during firmware updates, or field service person comes out to service the device. Is that built in, or is that one of the patterns that you mentioned?
So you could implement that by providing reported properties. So the answer to the question is that the device owns its lifecycle. So, and meanwhile, the cloud is just learning of it, but through queries or events, right? And so the device can report that it's currently out of service. You could inform the device that it should be out of service as a desired configuration. But at the end of the day, the device can report whatever it wants on the device twin. And that effectively will allow you to know what state and the conditions of the device. Now, if you had, for example, a kiosk, right? Then you also own that experience on the kiosk, and you would, in addition to sending out the reported property that's saying I'm out of service or I'm not currently in my update cycle, you would also put some UI if there was a UI for that device. What's interesting is that a lot of times we don't have UI for devices in IoT, and so that's kind of how you would do that.
Thank you.
Yeah, you're welcome. So on this side, thanks.
Yes. Hi. So the biggest concern with IoT is obviously security. So
Absolutely.
My question is, let's say I have IoT devices that are location sensitive. So if somebody picks up an IoT device and moves it to a different location, can the hub detect that the location has changed and alert the users?
Yeah.
Because
Yeah, so this depends on if the device is actually sending up its location to the cloud, because if the cloud is not getting information from the device, and like I mentioned during the talk, the cloud can't request something from the device. It can only wait for the device to send data to it for security reasons. So if the device is sending up its like GPS data as part of its regular telemetry packet, in a couple weeks / months, so spoilers, we're implementing route on body in IoT Hub message routing. So we heard you loud and clear. Routing on just the headers was not good enough. We will enable routing on body. And so if you're sending that GPS data, you can define in your message route that, like, push this message to a critical queue, for example, if the GPS data is outside some bounds. And so you will be able to soon, if you want to put that GPS data in the message headers, you can do that today.
Okay, thank you.
And this is a scenario we've seen a lot, right? Like, I have a very, very high valued asset that I really don't want anyone to walk away with, right? And so you can definitely, that's something that we see all the time, and definitely implement that with IoT Hub.
All right, thank you.
Thank you. Yeah, over here, please.
So right now, it seems everything you're showing is essentially a point-to-point solution. So I've got a singular device at the end of the stack. In reality, that's not going to be very much. I'm going to have a mesh network. I'm going to have 50 devices going into a gateway, whatever the case may be.
That's right.
Are you working on patterns or at least samples or help, whatever, so if I'm using an Intel gateway, just
Absolutely,
pick something arbitrary,
Yes.
that can say for firmware download for device A, do this, do that for device B, et cetera, et cetera.
Yeah, that's a great point. And in fact, that was really the core of our announcements this week in the Azure IoT, with Azure IoT Edge. Azure IoT Edge is going to enable you to deal with the diversity of protocols that you have on the edge, processing that you're going to need on the edge as well, and even offline, for example. So, and even mesh, right? So if you, for example, have a mesh network that you need to support, for example, I was just talking to someone yesterday about an agricultural scenario where they might benefit from LoRa, for example, and then have their own LoRa station that covers their 5 kilometers farm. That's an example, a great example where Edge really shines, and you would be able to enable that Edge network from the Edge device down to the sensor, and then turn around and have that connectivity back to Azure IoT.
So Edge is really going to be your guys' intermediate step between hub, edge, and then physical
That's right.
layer.
And that's right. And with Azure IoT Edge, you'll be able to manage all those devices, even though there's an edge device and a gateway in the middle that's enabling the connectivity and the diversity of protocols.
Right.
Thanks a lot. Yeah. Question over here?
Is the group working on anything related to low bandwidth communication to these sorts of edge devices, specifically things that go beyond TCP-like communication, specifically the Iridium satellite network, for instance, we do work with, and it's extremely low bandwidth, extremely terse with its communication, and things like MQTT don't really work across those bandwidths.
Yeah. So we do have an open source protocol gateway that you can use to act as almost an intermediary, translating between whatever protocol that's one that we don't support and the IoT Hub, which kind of helps you help yourself. We don't currently have any plans about other protocols that we're supporting in the near future.
Thanks.
Yeah, and we have customers that have very large ships that are in the middle of the ocean and don't have Wi-Fi signals or 3G, 4G networks, and so they definitely have leveraged the capabilities of being able to use satellites and communicate through the satellite back to a cloud gateway with the protocol gateway, and then to IoT Hub.
Yeah, because the end result is we get HTTP or something.
Exactly,
like that, but
exactly.
We can't use MQTT over that.
Absolutely.
Okay,
Yeah, great point. Thank you.
Okay, I'm new. Actually, not new. I don't know anything about IoT, so hopefully I'm not asking
Welcome.
a stupid
We want
one.
more of you.
Thank you. Okay, so apparently, I think your obviously recommended way to configure a bunch of devices would be asynchronous model.
Is to what, sorry?
Asynchronous.
Asynchronous, yes, that's right.
You don't do direct interactive.
That's correct. That's
sequence.
exactly right.
But let's say if I'm trying to configure a bunch of devices at the same time, maybe it's okay because I could monitor it, see. But let's say I'm just keep going, like every day I'm adding a field or configure a field. And in most cases, everything works fine. So I don't really want to monitor again, always monitoring the configuration success rate or something.
Right.
How about, do we have a standard way like saying, hey, after 10 minutes, maybe, if something is not coming up or
Right.
something has not done yet,
That's right.
then alert me.
Yes.
Is it a standard way to do it, or you have to write some special?
Right. So we provide the ability for you to query or register for events on things. And then you could, for example, connect those events to something like Stream Analytics that would then allow you to run a query that says the absence of this or the moving average of this signals over a period of time. And so when you can connect IoT Hub to Azure Stream Analytics and enable that type of analytic query to figure out.
So that's a standard sort of recommendation.
Yeah, absolutely. Yeah.
There's a standard pattern. We can't really say you should do it in at 10 minutes or what have you, because we don't know how big of a configuration you're trying to apply.
Thing, but
right,
as long as the process itself is standardized, so I could just do it.
Yeah, and this is why we published the patterns that Juan mentioned in the talk of here's how we recommend like the standard way of doing these various types of operations.
Okay, got it.
Thank you. And when you go and you stand up an IoT Hub and a Stream Analytics job and create a Stream Analytics job, what the beautiful thing about this is that there is no code in doing that. You literally go to the portal, you stand up IoT Hub, you get devices, that part is, there's some code there. And then when you create a Stream Analytics job, you just say, the input of this job is the IoT Hub. And then the output is a service bus queue or something. And then you start it, and it just works. So it's a really nice experience to be able to configure that.
Okay,
Thank you.
Thank you.
Hi, you've shown us some pretty cool things in IoT
Thanks.
Hub and in Edge also. We saw some other cool things. Can you describe whether you would expect those two products to merge or whether they're separate and under what circumstances one might be interested in looking at Edge versus the IoT Hub as you've described it today?
Yeah, most solutions are going to need an Edge capability. We see a lot of scenarios that are we see scenarios that are cloud only, device to cloud. For example, how these garbage cans in a city, we want to figure out what the heat or how full they are, and you might put a 3G, 4G modem on them, and then figure out population of devices. And scenarios like factories, for example, or situations where you have a lot of devices that potentially are a lot of legacy devices that need translation protocols. So the majority, I'd say, of IoT solutions are going to require Edge, and you'll be able to use both together. And I think that's the point. They actually work together. It's the same team building it, and they're designed to work together. Thanks a lot.
Has device twins and direct methods been implemented in the .NET SDK for the client now?
For the what, I'm sorry?
For the client side?
Yes, yeah, we have C# SDKs. We have Node, Java, Python, C on the device.
It's only Node and C# at the moment for methods.
Oh, yeah. For methods
we are actively working on the rest of them.
That's right. So for methods and device twins, we have MQTT protocol support. We're also adding AMQP support for that. And the libraries are also going to be coming in. We have a number of libraries, so we're continuously working on those as well.
Do you know anything about the timing?
We will make an announcement. So if you go to, blogs.azure.com, or just azure.com, and then the blogs one with the IoT filter, we're trying to get better at actually publishing blog posts saying, hey, we've got this new thing in the SDKs. So keep an eye out on that area in the next month or two, and we'll have more to announce around that, and saying hey, now it's supported. I think we just said that Java is the next one that's teed up. In the blog post that went live 2 days ago about some of the improvements to the device management functionality that we announced here at Build.
And if you need a specific one, I'll just love get your email and understand which one to make sure that we're helping prioritize that as well. Yeah. So if you can stick around just for a moment, we're almost done. We have a minute left. So I'd love to get your email and get contact. Yes, over here.
Yeah, so if you do a firmware update for a Windows 10 IoT Core device, what would you typically include in an update package besides the actual application?
Yeah,
so
great.
Talking more about the operating system, parts of the drivers, and so on.
Yeah, so the interesting thing about the Windows 10 implementation of device management is that it uses the same core building blocks of device twin and methods, but it actually enables the endpoints that are for Windows. So for example, you can update a UWP app through that same interface from the Windows Store, right? And you can then also control the Windows Update capability, which is way more complicated than anything that I want to really be discussing, right? Because there's years and years and years of investment there. And so what you basically get is you get all that infrastructure, and you're able to control it through IoT Hub. So there's really not a firmware update for Windows 10 Core. It's really more application and software update as well as OS updates.
So I think we're out of time for questions, and we need to give the room back to the conference organizers.
Yeah, thank you so much for coming.
Thank you so much for coming. Juan and I will be outside the room for a little bit to answer any other questions that you either didn't want to ask on a mic or just to chat with us afterwards. But thank you so much for attending.
Thank you.